So today we have the CodeChef contest, and let's try to attempt the contest. So we are here with the CodeChef contest. Okay, so it's 199 starters. Let's do a few things. Set up the folder structure first of all. Okay, so just get that code dot. So we got the VS Code right. So here, okay. So I did not. Okay, so only code dot. So we get the structure code, and it's a CodeChef contest, and it's plate 199. Our first problem A dot cpp, and we have a broiler template. Okay, so we are ready with the CodeChef contest. Let's get to that. So this is the first problem, second problem, and third problem. Okay, so center and total type of problems. Currently, emphasis are colored with the type, color, and then you want to. Okay, with the color I, AI. Okay, thickness of the color, all that emphasis onto with color X. Specific pens with color X. Okay. You know, number of minutes you get to, okay. So we just find the uh or take the we have this. Okay, go. Increment it and oh we have the max element, okay. It's colored with type 1. Right. Max plus n minus of CNT max. So we just get that. So let's see whether this works or not. 116 this one is CNT dot big. Okay, so we got a solution right. We just get the max element and then we just kind of find the index. This should work. So this should work, I guess. Yeah, I got the solution, correct solution. So let's get the second problem. Given positive integer and you can do the that's one another to open it. So then change to n minus 2 and by 2, which he did. Okay. You know, find the number of different what is the form if you have to when you starting with n. Different positive integers, okay. Yeah. First of all, that's okay, fine. Mm-hmm. So the parity fine. So we have kind of two parities. Smallest number you can get with parity. Okay, so first of all you have the parity. Mm. So what is the smallest number you can get with parity of? Oh, even parity, not parity. Okay. Oh, I'll set to the toilet template and time complexity required. Okay. So if the parity is two, it's gonna be one number. Okay. 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 So one an increment number of numbers. So CNT, which two it's gonna get two numbers. N plus one by two, n plus two by two, n plus one by two. So for a not number like one. Okay, so it answer equals to n plus two or else one. So this is answer. And this is another for the same parity. And we'll have the same parity, right? Out of these parity numbers, which one divided by will give us this? So, so suppose this is an even number. That's about to get odd. At some point, you get some odd number. What if it's even? You'll have some power of two. Suppose we have, then we reduce it by one, you get the odd one. So that is a very thing. Okay. Now one note. We'll see. Let's see. Okay. This is M is even. Okay. This is what you can get. Then N is odd. Then it is odd and you want even. 7 by 2 is suppose 3. So if opposite parity number, if N is even, worst case else. See, the N by 2 is odd. This is odd. or right shifted upon 2. Okay, so else in the other case, what we do is when the n is what? Odd, int even equal, so it's again another same kind of thing. So if n by 2 is odd, then it will be n minus 2 on 2, else it will be n by 2. So this is what we do. Answer plus equals to even upon 2. Even right split by 1. Okay, so you just see out the answer. So this is simple calculations. So there was not much of rocket science here. Oh, quick. Okay, one, two, three, 5, 6, 5, 7, 5, 6, 5. So you got 7 in the second test. So let's. So it's for the 9, how what will be the answer? Always stick for 9. It's odd and 9 by 2 is 4. So we can get two numbers 4 and 2. So 9 plus 2, 11 upon 2. This is 5 plus 2, 7. It should be 7. 1, 3, 5, 7, and 9. These are the numbers which we can directly get. And greater than 1. 5. So here are 5 numbers. Else if you do, okay, and it should be, 5. Okay, so this will know. This is just commented out. 165. So this should be done. So I guess this should work. Submit. I guess this should work. Yeah, so I got the acceptance. Third problem. Let's read the first file. C.cpp broiler template and just get this. Give an integer n. Construct a matrix n into n. Okay. That's why it is okay. Last. Okay. Represent the element the ith row and jth column. Okay. Set of elements such that ax y is equal to. So what is this problem? Uh, Positively we will solve this problem. Let's see if I can solve it. Okay. With the set of elements ax y x y. We have to construct a grid. Okay. Set of ax y such that x equals to I exactly 1, x equals to I, and y equals to 3 forms. Okay, so we are going to set up our elements excluding the same row and same column. Okay, so it should be max of, okay, it should be max of that. Okay, you will give an name, right? Okay, you'll give an name. Okay, so you have given an name, you have to construct a grid such that it should be max of them. So what we are asked to do here is, we have to construct a grid of what? N comma m grid, or n comma n grid. So let's understand the first steps. So suppose I have to construct a grid for n equals to 2. I have to construct a grid. Okay. So how can I construct a grid of, so 0, 1, 2, 3, and up to n I can give n minus 1. Yeah, this is what is happening. And the last activity has 0. So you don't have a 2. Yeah, this is the solution. So you just fill it with this way, right? Okay. So we directly take the end. Okay. So that's all. I guess just printing the solution. Okay, let's cross check with n equal 10. First test case and we get 10. I have this works. Coding problem is problem 3 and just carry it, submit. Direct typing, there was nothing much special over this problem. So we done with 3 problems. What was there this problem? Like it was quite a strong typing. So we got to the fourth problem now. Really quickly, I guess. And I would say nothing much was there in the fourth or third problem. Just printing was the thing. And rest of the thing was simple printing. So let's get to prepare a file for the problem D. See, broiler template. Uh, we are given two arrays A and B. If it's possible to form array C of length n satisfying the following conditions. Okay, okay, okay. So he's asking how many letter. Okay, this should be simple again, I guess. So constraints are huge, but here we have a simple limit. Okay, so said that says that this should be strictly increasing. That's the condition. So we pick the minimum of both of them at each instance. You pick the minimum over here, and other you pick maximum minimum. So number of ranges that satisfy the condition. So okay, so constraints a bit. Okay, let's take the input first of all. There are n and two arrays, and we have to find out the lengths L and R which are perfect. Obviously, you take the minimum and try to make it increasing. Okay. Okay, so if we take the maximum of then what is the length you can get? So we'll apply DP or DP. So oh, I got the solution. And take the vector of int A of n and take the B of n. We get the solution. Okay, go. And person pose a impose for we take the input. First of all, not doing anything special here. A vector of if you take the AI, what is the maximum length we can get? If you take the BI, what is the maximum length we can get? Vector of int dp of we start. It's gonna be 2 initially, and No, we just iterate for the DP table to start from n minus 1 and go to greater than equal 0 or greater or equal 0 and it's going to be I minus 5. And this was the previous state. Okay. Okay, so we can take instead of matrix. We can define a matrix instead of both of them. Vector of int. Okay, and it's gonna be what? 2 and vector of int. That's gonna be of n. What's a0, a1, right? And it's gonna be a of I comma 0 if it's greater than I plus 1. Okay, so we can just push back infinite for both of them. Okay, so a dot push back. Oh, okay, I can push back int comma int max. I guess should work. A of I is greater than a of I plus 1 comma possibility. So dp of I comma 0 would be max. You can just initialize everything by 1 instead of that. So base case would, I can directly give a 1 for the base case, and this would be the base case. And dp of n comma 1 would be a 0. Everything is same. Okay. Or instead of pushbacking this, we can just directly. Okay, I can just. Okay. Another important thing. Crazy. Go with n minus 2 and just go with 0 and yeah, a of I comma 0. A of I plus 1 comma 1 j. And again similar kind of control L and just copy the line, control V and format document. And it's for me here 1 and 1. I guess this should be the solution. Okay. Or no number of subarrays, so it's LL answer. I comma 1, see out answer. Yeah, let's see if this works or not. What? Oh, what's wrong? Okay, so what we have done is pretty straightforward thing. Like there is nothing out of box we have done. Mm, mm-hmm. What do return? Kind of supports wrong. Okay, let's go LT to kind of now debugging it. What's wrong here? Okay, fine. So mistake with to here. So it's gonna be okay. Sarah, I guess it's I can figure out what's wrong. Okay, up to one. It's good. Okay, fine. Okay, up to one comma I just got the solution. It's just of k comma I plus C out there. So how this should work? This case is yeah, that's another thing. Short 563 is the solution. It's just yeah. So got the solution right. Just have a solution. Submit and click on submit. Yeah. So you got the problem D correct. There was nothing too special after problem D. So let's go to problem 5 now. I don't think anything was really too out of box thinking to here. Everything was direct. Everything was implementation. There was nothing special. Applying dynamic programming. This was a straightforward DP. So let's go with problem number E. I should be able to solve, I guess. I'm not sure. This might have some graphs or trees. Exactly. Okay. 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 Let's also maximize above once minimizing where both lays out twice and let's go. I don't know. This thing really I don't know. Looks a really tough problem. But basically in this kind of problems you need to have idea of the topic involving this problem. Like without having idea of what the problem is intending, you cannot solve it. So let's even check out the last problem just in case we have some segmentaries or families, we still have the chances to solving it. Guys, first of all, at some point we have to do XORing. We keep on doing XORing. Okay, so when we do XOR with both elements, so दोनों में है, then we just get out. Okay. So third test case, how it's three. Sorry. Okay, so how much three in the test case? Okay, not necessarily distinct. Okay, this is the way. Not necessarily distinct. If you realize this point, then the problem becomes like you can make a few of them zero. So let's what's the constraints? So making first of all, what we want to do is we just want to make some of the elements zero, such that Zora is done. Yeah. So Elise wants to maximize and Bob wants to minimize. When we erase one element, that will become of odd count, even count means the XOR of total XOR has become zero. Hence, okay. So what are the elements? So I guess okay, exactly once, exactly once. So let's understand. So we have prefix and suffix XOR, and the problem is solved now. I can solve this problem in n square. So this problem can be solved in O of n square, but obviously O of n square doesn't make any sense. Well, like it's about bit counting now. This should be able to. I should be able to solve this, but I guess the standings would just flat like hundreds of submissions for the problem. This looks really tricky. Uh, okay, so exactly one. So let us. Forms of hi. So ls would want to make what? Zero. Some point. And Bob will make what should Bob make zero? So this has been zero. What is the maximum XOR, minimum XOR? Number of numbers having odd count, sum of odd bits. So what is the solution now? So what we'll do is solution is fixed now. Fix. ALS operation and find Bob. So Alice does this, and what would Bob do now? What would Bob do? So Bob, basically, when would Alice want to merge? That will not affect the total exam. So Alice, so Bob would do zero. Bob would either do nothing, or Bob would do what is the minimum exam that you can get for this? Oh, even count, not count. Well, like I don't. Alice would merge so that दोनों में if both of them have that, one of them has this. Okay. I can solve it in n to the power 4, obviously. Okay. I just would like to just check my college standings. I don't know. What is the problem? Yeah. This is the problem. Okay, so it's gonna be increasing. Mm, what would Bob do right? At least has done this. Never of which that he can make even. That is what is his goal. You would like want to make so he can always make it even anything. So he will definitely make the MSB even. So no doubt about it. So what is the maximum MSB you can get? So if you make this MSB even, it does not make any sense. So what are the Max? Can you get this as MSB? That is what you need to think of. If I don't know. Basically, I don't know. Really, I don't. What's going on here? I'm not really thinking. Start thinking. Try with the test case. 1034. So 1034. So 1 has come 2 times and 4 has come 1 time. So these are odd ones. First of all, if you kind of try to make it, so you can do a self XOR, and then what will Bob do? He will do a self XOR. Answer will be 3. These two are odd. If you make them even, he will ignore it. Trying to solve it bit by bit. Can you get this as MSD? Solving a problem bit by bit, understanding it bit by bit. So what can we do here? I mean, like solving bit by bit. One of the things is solving bit upon bit, right? One approach. So considering with one, so it's 1010. So what you can do is, or do a self. Oh, start with MSB. Sorry. So 0001. Oh, can you get it? So ignore it, and it does this. So it's not possible. Okay, fine. It's not possible. Can you get an odd count of this? Yes. Come into section to this thing two. Can you get an odd count of this? Yes. So you can get odd count of both, so you can have a two. So if this one of them was having an odd count, so you can definitely get an even count, odd count for two, because everything has some more. Then you can do that. I'm gonna schedule. Okay. You should never feel stuck. Let's go with this last order. AI extended by more K is equal to I terminal and then delete AI plus one. Okay, count the number of arrays. K of times. So AI plus X and Y. X and Y is extended to K. Modulo K. Every element is less than K. So number of distinct arrays that you can get. X and Y plus X and Y is number of one. Okay, number of distinct arrays you can get. And what are the values that you can get here at the back? Okay, okay. We move these two. Get to the second back. So number of distinct arrays. Understand this problem. This looks even more tougher. I mean, like no idea. Zor game again, no idea. 3 second time limit. Some one finder, so bit by bit is okay. Need to be simultaneously few of them out count. And then no element is having that two of them simultaneously. Um, really, I don't know. If we cannot get one of them, most really I don't know what to do. Okay. So bit by bit we consider on the 2 years. So the big arguments with the word count. To make this bits with the yeah odd count. All of that. So I don't know. Practically I don't know, but this is again too tough. Gentle for another business. Let's go. I go. So number of errors that you can get. So So, let's understand some other problem. So we have a modulo AI and we have a modulo AI plus one. So what are the modules that we can get to two modules? So we have one and two for modulo three. You can get a modulo zero. You can get a modulo of one. You can get a modulo of two. Fine. The same modulo. Suppose you have four. You have modulo of one, modulo of one. You can get all modulus. With this. So so you can get the all modulus GCD. So you can get all modulus GCD. For both of them, I can get the GCD of modulus of all GCDs. Okay, so we get in close to the problem. Suppose you get 1,000 and you got a one, a two, and four. So you can get all modulus divisible by two at some point, right? Starting from zero, you will get everything divisible by that. So that's one of the things. So you have got all modulus divisible by that. So the number is simple. Like you can get all modulus divisible by number, right? Okay. So once you got, so what are the divisible modulus that you can get? So underscore of GCD of AI plus one is we can get. Okay, fine. So when you take kind of take keep on taking GCDs, so if it gave us solve the problem, we have very simple number of sub arrays that number of arrays that was with. So let's understand with the example. So 0, comma 1 number of arrays that we can get. You can get again practically all arrays. So 1 to 3. Yeah. So you can get everything. Yeah. So we add one thing, right? Okay, so that is the number of ways in which so it's center for nine, right? Number of arrays. Once you get a modulo of everything you can get, whatever elements you can come, you can get everything again. DPS getting this is previously we got this. So this can be solved this in the DB. Let's start off with it. Oh, what are the values that you can get? Uh, we fix the length, maybe. So this is clear, okay. Understandable also. GCD is quite clear. Second test case, 2 2. And 3 you got. So the GCD is again, first of all, number of operations that we apply. Okay, so as I understand about what happened. So if we apply operation, then that multiple thing may work. If we don't apply operation, so far we can get errors. If we apply operation, okay, we can get whatever you want. Okay, applying coordinate compression will not make any sense. Okay, so let's understand the test case of 2 comma 2. 3, we can get a GCD of 2. So it's 2 can get 0 2. So you can get 0 2 2 2. So the answer is 3. So it's 2 2. This is one errors, one errors. So it's 2 2 is one of the errors. 3. How did he actually get for it? Okay, I'm not applying any operation, applying one times. Okay, so 0 and 2. Why can't I get one? I can even get one also. So I see. So 2 is the most simplest thing you can get, and 2 into k upon 3. So what are the modules that you can get? So who is the basic modulo that you can get? And you kind of keep on multiplying, multiplying, multiplying. Okay, so what is the modular community used to? So, until say 6k minus 1. So 2 into k minus 2, you can get a modulo. Then you cannot make any progress. So, so need to evaluate some point, not any problems. Else, if it was 3, you could make progress to 2, and after 2, you get set. So, again, it's gonna be the GCD of both of them, I guess. So GCD of the value that you get in that is the basic element. G underscore GCD of what? AI, AI plus 1, and then value. I'm able to get this. Okay. So frequent 3 GCDs. Right? You know, always get a GCD of 1. Both are of opposite parity then. If they are of same parity. Okay, so basically if you have 3 and 6, you can always get 6. Taking GCD. Fine. Up to here it's fine. So that's why there you go. So we understand the fourth question is 4. The 4 zeros. And we have 1, 2, 3. 0, 1, 2, 3, 4. 1, 2, 3, 4, 4, 5. So if you have to go the first test case, it's 2, 4, 3. What? 2, 4, 3, and the modulo is 6. So what we can just take modulo, uh, apply operation for this, or we can apply operation for this. And apply operation, it's going to be this, going to be 2, 2, 2, it's 2. So you can get 2, 4. Number of ways that you can get 4. What are the different arrays that you can show for? So, answer variable. So, answer variable times this, and else number of arrays so far, or ans variable, and number of different arrays that you can get so far, and then we combine them, combining them. So, what are the devices of K? Those can only, okay. We came out to the solution. Devices of K can be the GCD. SQRT 10 to the power of screen to 10 to the power 4. Okay, that would work. So finding the devices is just a simple step. So we have 3 seconds time limit, right? Okay. You can get a 2. You can get a 0 to 4. So 0 3. After that, yeah, from there you can get a 1, then you can get a 1, and then you can get a 0. So 1, 2, 3, 4, 5, 6. A lot of errors still left. Why this operation machines? Okay, so that is another case. Like this operation first, not like this. Okay. The number of distinct errors sending at that value. So other GCD, fine, that is fine. Other GCD, uh, same as होगा, but I don't know what to do. Obviously, I can solve the problem in a very high time complex. Obviously, uh, I cannot kind of do that. You need to understand that value never remembers people. Okay. I'll take now. 2 study solid. DK 5 common segment is not. Number of parents. K is very huge. If K is small, then I can solve it. What? Okay, okay, okay. I can erase. Sorry, sorry. Okay. No, 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 erase. But bye. My hair is. Bye. Implementing this is not complex, but understanding this problem is difficult. So number of surveys indicate a value. Total values then previously ending at some value. So keying to an obvious is always and not after. Ending at some value. Apply, not apply. Apply, not apply. N minus one operation is totally we can do. So this there will be a lot of distinguish modulos. That's why you're using modulo. What are the number of values that you can get so far? So that we are ending at the value. Number so far that you can get ending at the value one. Mint answer. Okay. I guess I don't know. Proper solution I don't know. I thought a lot. I guess I can just do some let's have some. Okay, this thing again. 1 second limit. This is interesting to see the 1 second limit. Okay. Okay. Oh, got a two. Okay. What one? I'll try more foods. Okay. Okay, so I got the solution. You have to take the rum ranges, apply, take the GCD, and check GCD of K and all the levels in rate. Okay, GCD will reduce. Mhm. Binary search. Okay, so we just You have the devices, okay. So far, I just use this. After you take the GCD, it's gonna be the square root of k. Mm-hmm. 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 It's gonna be number of members that you have to take the GCD to become. Hmm. This is too hard, but can be solved. एक रेंज में GCD ले रहे हो तो ये हो रहा है सेगमेंट ओके reducing the factor. What are the different diseases that we can get started from the 18x? मेरे को गुस्सा उठ रहा है मैं निकल गया तू मेरा दिमाग खराब So, first three. First one we got three. Second one two, three. So it's gonna be one, one. Oh, and obviously we are not considering everything. We want to range some further. And suffix dot push back mint of one. Suffix dot push back. This would be what are the indexes? Okay, wait. We have to kind of consider everything. What are the indexes? In which we will get different values. That's sound run. Yeah. I'm close with this, but okay. So there will be a difference. So again, mhm. GCD, GCD. Okay, when we go to V3. So one again, this would be okay. So V3 to since the way number of what was the okay. So number of distinct arrays that you can get. Indicative values. Ah, okay, so let's end here like a fought really hardly.